Hello, everyone. Thanks for joining the talk. My name is Aleksandra Osowska-Kurczap, and I'm Machine Learning Manager at Allegro. And I'm really excited today to share with you the story of how we built a unified two-tower recommendation system to scale and innovate at Allegro. So before we dive into the technical details, a quick introduction to the Allegro itself. We are a leading e-commerce marketplace in Poland and several other Central European countries. Our platform connects over 160,000 sellers with over 20 million active buyers. And our mission is very simple. We want to simplify shopping and selling through our marketplace model, seamlessly connecting users to the products they love. So in a marketplace of this size, serving highly relevant and engaging recommendations is like a very core challenge for the platform. So we faced three key problems. Firstly, our system needs to scale to dozens of placements across the whole user journey. Secondly, we can't introduce a very huge maintenance cost because our team is simply not that big to handle it all. Managing a separate model per every placement is simply not feasible. And finally, our system must operate on top of a highly volatile product catalog with new products and sellers joining the platform every day. So the core question is, can we build a single recommendation platform to facilitate all three key recommendation types that are omnipresent across the whole user journey on the platform? So the first type is Similarity product suggestions, Complementary recommendations are next, and Inspirational discovery. So as you can see from the image on the right, these three tasks are seemingly distinct, requiring rather a flexible solution. And we actually answered this challenge by creating a unified content-based recommendation platform based on very well-established two-tower framework that is certainly known to you all. To address the challenges we discussed in the beginning, our method is built on top of three core pillars. As you can see on the slide, each pillar directly addresses one of our key challenges. So firstly, to solve the scaling problem, we phrase each recommendation task as a content-based filtering problem, which is defined by some kind of an DLRM encoder and ANN index. Secondly, to minimize maintenance costs, we purposefully redefine seemingly distinct use cases to fit our two-tower framework. This single framework can handle multiple tasks with a shared backend infrastructure. Finally, to manage our volatile product catalog, we built a robust product representations on top of some less volatile features like product title, categories, etc. So let's dive into the first task, which is similarity search. This is a very classic vanilla item-to-item recommendation problem with the goal of showing users similar products to the one they are currently viewing, just for the purpose of, for example, comparison. So if the user is looking for a pink bicycle, we want to recommend other bicycles. The encoder here is the Similarity two-tower, which is trained on some co-viewed traffic to learn rich content features. We used typical solutions for large-scale recommenders. So we use sampled softmax and mixed negative sampling to train the model. And the offline inference is handled by ANN index, which is refreshed daily and is based on the Defines library. Next, we have complementary suggestions, a more complex task. Here we aim to recommend products that are often used with the item the user is browsing. So if a user is looking at a bike, we want to suggest here a helmet or some gloves. The encoder here is the complementary two-tower. In comparison to Similarity two-tower, it includes some additional small features to handle the business case for this specific placement and uses a projection to some specially crafted set of complementary categories during the inference. This model is specifically trained on co-purchase data to understand which products are bought together. The online inference, as previously, is done with an ANN index with a very small twist. because we add the interleaving of the recommendations across multiple complementary categories to ensure diverse set of suggestions. Our final task is inspirational recommendations, and this is about showing users appealing and engaging items they might not have found out otherwise via search, etc. So in this case, it might be some kind of an accessory for a new bike, like a basket or some lights. We reuse the same backbone encoder for Similarity to Tower. And the key difference here is for the serving, so the indexing and the request, because here we use hierarchical INN index with embeddings clustered via even simple k-means. The query itself consists of a sequence of user topics, which are based on users' recent activity aggregated to category level. So we also use here some kind of like an interleaving, as we've seen in Complementary to Tower, for increased diversity in the results. We validated our solution with extensive A/B testing on Allegro platform, and as you can see, our unified approach successfully boosted key business metrics when applied to multiple placements across product page. From the upper table, you can see the results for the first two solutions, so for the Similarity to Tower and Complementary to Tower. For both, we saw statistically significant improvements in CTR, between 1 to 2% on both mobile and desktop devices. The models here were used as a fallback for our collaborative filtering algorithm that was presently present on the product page. In case of inspirational recommendations, it was a launch, so we didn't have any competitor to beat in an A/B test. Here you can see in the table 2 the results from two different front-end implementations: a carousel view and an infinite feed view, which enabled the user to actually infinitely scroll through the results. And the introduction of the infinite feed showed some statistically significant increases in CTA, so call to actions, and in conversions, while both implementations significantly reduced bounce rate and exit rates. Building this unified framework has opened up several exciting prospects for future work. We are focused on implementing some real-time personalization on Allegro right now. We are also trying to get on the hype of foundational models. Finally, we are exploring some optimal blending between organics and sponsored content. And thank you very much for your time and attention. I would be happy to take any questions now or off the main stage. And please come meet me and my team at the poster spot number 3.
How do you build the complementary categories mapping used during the inference from the complementary TT?
It is actually quite complicated thing to build from the scratch, but we had a privilege of reusing few of components that already had been built on our platform. The first one, it was simply a statistical model on co-purchase data, which serves quite nice suggestions already. Apart from that, it's really useful to also reuse some in-house knowledge from the data experts, so from maintainers of specific categories. And for us, they build also some kind of additional mapping with complementary relations. And of course, if you don't have the data, you can try to grab it via annotation. So it's in other solutions that you can take.